All right, guys, for our last 7 problems from the study guide, we have the operational material, which is all of our simplification, all of our basic operations like multiplication, addition, and so on, and then our equation work. So there's really just a lot of factoring throughout this section. So for problem number 10, I'm going to factor this top left to be x times x minus 3. The bottom I'm going to factor to be 4x, and then I'll be left with x minus 2. This top expression is a difference of perfect squares, so I'll have x plus 2 times x minus 2. And then this bottom is a quadratic that I need to tackle with a times c, because I have that leading coefficient of 3, and then I don't have something that I can factor out of every single term. So here, 3 times negative 21 is going to be negative 63. Then I want to think what could add to make that negative 2. And that should be a negative 9 and a positive 7. So if I write this out, I'll have 3x squared minus 9x plus 7x minus 21. I can group those first 2 terms and then the second 2 terms. Take out a 3 and I'll be left with x minus 3. And then I'll have plus 7 times x minus 3. So this is going to factor to be 3x plus 7 times x minus 3. So I can cross this out and fill in 3x plus 7 times x minus 3. And then with these ones, you guys, we are looking to see what we can cancel out. So this x and this x cancel one another out. This x minus 3 and this x minus 3 are going to go away. And then an x minus 2 up here and an x minus 2 down there are going to go away. And so that means all I'm left with up top is x plus 2. All I'm left with down below is 3x plus 7. And that's my final answer there. So for multiplication, you just want to look and see what can factor, and then you're multiplying straight across. Number 11 is division. And so here I want to flip first, and then I can simplify. So I'm just going to rewrite this term so that I'm really multiplying instead of dividing. And then I got this 10x plus 70 down below. So I'm going to cross those out. Now I want to look for what can factor. So top left, I want to think about what multiplies to negative 7 that adds to positive 6. And that's going to be an x plus 7 and an x minus 1. Then down below here, I can factor this expression by taking out a 10. And then I'll be left with x plus 7 down below. So then I need to see, okay, my constants, I've got a 50 up top on the right and a 5 down below. That can cancel to be a 1 and a 10. And then I have an x to the 13th up top and an x to the 11th down below. So I can actually cross out the x to the 11th. And then over here, I've got an x squared because 13 minus 11 is going to be 2. So now I get to see if there's anything that will cancel out top and bottom here. This x plus 7 and this x plus 7 will divide. This 10 and this 10 will divide. And so I'm going to be left with an x squared and an x minus 1. And I'm just going to go ahead and multiply those together. So x squared times x will be x cubed. And then x squared times 1 will be x squared. So that's just going to be my final answer there for that one. Then, after our multiplication and division, we have addition and subtraction. With addition and subtraction, this is where the common denominators become important. So anytime I see a quadratic denominator, I'm going to factor. So this x squared minus 5x minus 14, I'm going to rewrite to be x minus 7 and then x plus 2, because now I can better compare denominators. If I look at them both, the one on the right is just missing an x plus 2. So I'm going to multiply that in up top and down below. And then I can add the whole thing on top of the same denominator, that x minus 7, x plus 2. So I'm going to distribute and combine like terms up above. So I'll have 10 plus 2x plus 4. Still the same denominator, hasn't changed. And then x plus 2 here. And then this is going to become a 2x plus 14 up top. And this is an x minus 7, and this is an x plus 2. And so I can factor up top if I want to, and I'd be left with x plus 7. Unfortunately, though, that isn't going to cancel with anything down below. And so this is going to be as simplified as my final answer can get. So a lot of times, unfortunately, our addition and subtraction does not work out quite as beautifully in the simplification process as our multiplication and division often do. So that's my final answer there. Then, number 13, we have some subtraction going on. Now this one, I don't have to do any factoring. I can just tell right from the get-go that my denominators are not the same and don't share anything in common. And so for that reason, everything on the left is going to need an x plus 8, and everything on the right is going to need a 3x plus 5. So I'm going to go ahead and fill that in. X plus 8 here, and then x plus 8, plus 8 down below here. Everything over here is going to need a 3x plus 5 up top, and then a 3x plus 5 down below. So I'm just going to go ahead and multiply up top. This 4x will become a 4x squared, and then this will become a 32x. And this is all over the x plus 8 and the 3x plus 5. And then this 10 is going to become a 30x. And when I distribute over to the 5 plus 50, down below I'll have x plus 8 and then 3x plus 5. So now I can combine like terms, but I always want to be really careful when subtracting that this negative goes both to this term and over to this term. So the 4x squared will stay by itself. Nothing can combine there. But the 32x minus 30x is going to be a plus 2x. Oops, that x got a little funky. Plus 2x. And then that negative is going to become minus 50. And so that is all over x plus 8 times 3x plus 5. Now, just to be careful, I want to make sure that I factor and check what's going on up top. So here I have 2 times 2x squared plus x minus 25. And that is all over x plus 8 times 3x plus 5. Now I have that quadratic up top, so I would want to check and see if there's anything that can be involved to factor. So I would want to check my a times c, so in this case 2 times negative 25, which is going to give me negative 50. But then when I think of factors of 50, I've got 50 and 1, I have 25 and 2, and then I have 5 and 10. And it doesn't look like any of those values are going to add together to make a positive 1. So that one is not going to factor, which means that at this point I'm at my most simplified possible form. Next up, we have a complex fraction to simplify. So for complex fractions, I want to, anytime I see a quadratic, factor just like I would with our work adding and subtracting, so I can see how the denominators compare. So this 4 is over x squared minus 9, which I can use a difference of perfect squares factoring pattern to break apart to be x plus 3 over x minus 3. And then everything over in that 2 over x minus 3, that's just linear, so I can't factor that up. And then on the bottom here, I have 1 over x plus 3 plus 1 over x minus 3. So when I compare all of these denominators, x plus 3 and x minus 3, those are going to account for all of the pieces that we see here. So if we multiply that combined term in, we'll be able to cancel all of our denominators out. So I'm going to kind of put big brackets around here, and I'm going to write an x plus 3, x minus 3. You can think about that being over 1 up top. And then I'm going to do the same thing down below, x plus 3, x minus 3 over 1. So when we bring it first to this term, notice how it is entirely up top in the numerator here and down in the bottom over here. So that's going to cancel out and leave me with just a 4. Then when I bring it over to this term, there is an x minus 3 up top and down below, which means I'm just going to be left with an x plus 3. So that looks a lot nicer already. Now when I do this on the bottom, this has an x plus 3, this has an x plus 3, so I'm just going to have an x minus 3 here. And then when I come over to the x minus 3, the x minus 3's will cancel, and I will just have an x plus 3. So now let's combine like terms. This is going to be 4 plus 2x plus 6 up top. And then this 3 and this 3 will cancel, and I'll just have 2x here. So this will become 2x plus 10 over 2x. And I know it looks really, really tempting, but I can't cancel those 2x's, but I can factor out a 2, which will leave me with 2 times x plus 5 over x, which is over 2x, which means my 2's will cancel, and I will have x plus 5 divided by x as my final answer here. Now we just have 3 equations to solve. For problem 15, anytime I have 2 rational equations just set directly equal to one another, I can cross multiply, which you might have learned as the butterfly. So I'm going to multiply this x by this x. So I'll have x times x, and then I'm going to multiply this 2 by x squared minus 8. So this will become an x squared. When I distribute, I will have 2x squared minus 16. I'm going to subtract this x squared over from this 2x squared. So 2x squared minus an x squared will be an x squared minus 16. I can either add that 16 over, or I can use difference of perfect squares, factoring. It's going to work out either way. And so my 2 answers will be positive and negative 4. So cross multiplication sometimes will give you a linear result as your final answer. Sometimes it will be a quadratic that you'll have to factor, like this one. Next up, problem number 16 tells us we're going to have to check for extraneous solutions, which means we want to watch out for having answers that aren't actually real answers. So when I look at this expression, I'm looking to find a least common denominator, but unfortunately my denominators are completely different, which means I'm going to have to multiply an expression that includes both. So when I look at this side and then at this side, I need to multiply everything over here by 2x plus 5 times 3x. And then over on the left, I need to multiply, same thing, 2x plus 5 and 3x. So when I distribute in here, the 2x plus 5's will cancel, and so I will have 3x times 7x plus 1. Then when I come over to the 1, there's nothing to cancel with, so I'll have the whole expression, 2x plus 5 times 3x. And then over on the right, when I distribute in, just the 3x top and bottom will cancel. So I'll end up with 10x minus 3 times 2x plus 5. So we have some multiplication and foiling ahead of us. When I distribute that 3x in, I'll end up with 21x squared plus 3x. Then here, I'm going to multiply this 3x by this 2x to get 6x squared, and then by the 5 to get 15x. When I FOIL over here, 10x times 2x will be 20x squared. My outer term will be 50x. My inner term is 6x, and then my last term is 15. So now I need to combine some like terms. Over here on the left, I will have 27x squared plus 18x. And then this is going to be equal to 20x squared. This will be plus 44x minus 15. So now I need to bring all of these terms over to one side. I'm going to subtract this 20x squared. And when I do that, when I subtract over to this side, I'm going to kind of loop around here. I'll end up with 7x squared. Then I'm going to subtract the 44x. So I'm going to subtract that from the 18x. So when I take 18, when I subtract 44, I'll end up with minus 26x. And then I'm going to add over that 15. So I will have plus